Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amar bin Arfanuddin. I'm from 2BEKG Section 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ishaq. I'm from 2BEKG S3.
My name is Shazwan Ikri bin Muhammad Lutfi from 2BEKG S3.
Today we will talk about finite and infinite surface charge. First of all, from our knowledge, there are two laws which is contain infinite surface charge, which is Coulomb's law and Gauss law. I will talk more about Coulomb's law. For its definition, Coulomb's law is the force attraction or repulsion acting along a straight line between two electric charge, which is directly proportional to the product of the charge and also inversely to the square of the distance between them. This is also applicable in finding the electric field due to any charge. The bottom of the slide, it has the basic formula for electric field, which is electric field equal to force per charge, which is F over Q. Then it can be converted into other formula, which is E equal to R, which is direction, times Q, which is charge, over 4 pi sigma. Sigma is the constant value and R squared. R is the radius. It also can alternate into the final form, which is E equal to 1 over 4 pi sigma integrate R direction times rho S, which is the electric charge density for surface, over R squared ds.
Okay. Next, we go to the Gauss law definition. Definition of Gauss law is the total of electric flux out of the closed surface is equal to the charge enclosed divided by the permittivity. The electric flux in an area is defined as the electric field multiplied by the area of the surface projected in the plane and perpendicular to the field. So, we can see this is the formula of surface charge, and it expands to the Gauss law surface charge.
For the next part is the infinite surface charge of the Coulomb's law. This formula is the formula that we obtain from the first derivation of electric field from the Coulomb's law. This formula also can be used for circular discharge and for the infinite discharge, which will be derived based on the diagram from the right side. By converting the diagram into the formula, we get E equal to 1 over 4 pi sigma integrate 0 to 2 pi, which is the limit for the theta, which is in the circular direction in the diagram, which is 330 degree. Integrate 0 to A, which is the radius limit from the origin to A, times negative R direction R plus Z direction H over R squared plus H squared power of 3 over 2 times R dr d theta. R dr d theta is the formula that we get from the Z surface. Then we simplify, we get E equal to Z direction rho S H. H is the height based on the diagram per over 4 pi sigma integrate 0 to 2 pi integrate 0 to A times R over R squared plus H squared power of 3 over 2 dr d theta. Then we simplify the integration. We get E equal to Z direction 2 rho S h over 4 pi sigma times negative 1 over square root r squared plus h squared. Then from 0 to A, and for the theta from 0 to 2 pi. And for the final, for the circular discharge formula is E equal to plus minus Z direction rho S over 2 sigma times 1 minus h magnitude over square root of A squared plus h squared. For the infinite disk sheet, we take from the final equation for the circular discharge, which is the alpha for the infinite discharge is infinity, so the final formula for the infinite disk sheet is equal to E equal to plus minus Z direction rho S over 2 sigma.
Okay, next we move to the infinite surface charge Gauss law. From this section contains two parts, that is discharge and rectangular charge. So we move to the first one, discharge. You can see Q equal to rho S ds is the formula of surface charge. So the first thing is we must find the surface area. You can see it is like cylindrical, right? So we must use the concept of cylindrical to find the surface area, and we'll get this answer. Rho S pi r square equal to 2d pi r square. Pi r square we cut and get this answer. D equal to rho S over 2. As we know, D or flux density equal to sigma E. E is electric field. So to get the E, we must convert sigma over to the D, and we'll get this answer. Okay, next, second part is the rectangular charge. Like before this, you can see Q equal to rho S ds. That is, first thing we must find the area. We know that the flux density will be flow out from the top and bottom, which means have two area, right? So from this derivation, we'll get this answer. Rho S A equal to 2dA. Okay, A we cut and get the D equal to rho S over 2. Like before this, D. To get E, we must convert sigma to over D, and we'll get this answer.
So Assalamualaikum warahmatullahi wabarakatuh. I will continue about my video assignment. So my part is about to explain example of question and answer. So for my video assignment, I will explain this example. The question is so you can see the question. So the question want us to find the total charge on the sheet, the electric field at 0.05, and the force experienced by negative 1 microcoulomb charge located at 0.05. So this is the question, three questions. So for A, total charge on the sheet. So total charge on the sheet, the formula is Q equals to rho ds, rho equals to the integrate rho s ds. So rho s equals to the rho s is given from the questions, which is this. So ds equals to x dy over dx. So that we just create this equation. So which is dx equals to 0.1, limit ds is 0.1, dy limit is 0.1 also. So this is the equation. So this part A has a special method, mathematical method. So we can see that so I will simplify the method which is ds is equal to 1 over 2 dx square. So we can see that the method dx change to dx square, and dx square we have also 1 over 2. So this is, so dy also have the same method. So this is, so after that we get this final equations. So then we just calculate as usual. So we get the final answer is 33.15 nanocoulomb. So this is the A answer. So for B, the electric field is at 0.005. We know that the electric field formula is equals to integrate rho s ds ar over 4 pi epsilon r squared. So the derivation this is the derivation where r minus I prime, r equals to 0.005, r prime equals to x at 0. So the answer is the answer of the substitution is negative x, negative 1, 5. So then we just put all these value properly into this formula. So then we get these final questions. So after that we get the final answer is negative 1.5, negative 1.5, 11.25 V over M. So for next question C, the question asks to find the force. So force equals to Q E. So Q has been given from the question, negative 1 microcoulomb. E is the V pi, the final answer of V pi. So we just multiply and we get the answer 1.5, negative 11.25 micronewton. So that's all from that's all the example from my video assignment. So that's all. Thank you.